How are you all? Hope you are enjoying the series of solving previous year questions of NEET examination. We are close to the fourth chapter, that is laws of motion. Okay, let me start numericals which came in previous NEET based on the chapter laws of motion. Let's get started. Now observe question number 1. So question number 1, it's based on Newton's first law of motion. Okay, let's see just what is first law of motion. Newton's first law is, so we know that any object which is initially at rest are under constant motion until unless an external force acts on that object. So that means acceleration of that object is equal to 0 if and only if F net acting on the system is 0. So this is based on law of inertia. We call it as based on law of inertia. Acceleration acting on that object is 0. It doesn't mean that velocity is 0. If acceleration is equal to 0, velocity of the object is equal to constant. So velocity is equal to constant. It means object either at rest position or initially moving with a certain velocity, then that velocity is going to be remains constant throughout its motion. That is the meaning of acceleration is equal to 0. Now look at the first question based on this. So physical independence of a force is a consequence of, it is not dependence, independence in the sense net force acting on the system is 0. So which law is applicable for this? Newton's first law of motion. Very good. Next, move on to the second law. There are so many type of numericals based on Newton's first law. So it is also called as equilibrium, right? If F net acting on the system is equal to 0, then this is also called as equilibrium. So whatever the system which is in equilibrium position, we can apply this law. Okay, so let's see numericals based on Newton's second law. Majority of the numericals in competitive examinations are used to come based on the Newton's second law of motion. So what does it this Newton's second law of motion? So Newton's second law of motion describes net force acting on the system is directly proportional to change in momentum, rate of change in momentum. This is the actual formula of Newton's second law. So I can replace it as F net is equal to dp by dt, where p is momentum, linear momentum. That linear momentum is replaced with, it is linear momentum. What is the formula for linear momentum? Linear momentum formula is P is equal to mass into velocity. So let me substitute that. dmv divided by dt. So here both m and v may be variable with respect to time. If they are variable, both m and v are variable with respect to time, I can write down this formula as F net is equal to, this F net is nothing but net force acting on the system, is equal to m into dv by dt plus v into dm by dt. So this is by using uv formula. So hope you know uv formula. uv differentiation is u v dash plus v u dash. By using this formula, so this is applicable if both the terminologies are variable. As m and v are variable, that is what I am considering, then F net acting on the system is equal to m dv by dt plus v dm by dt. Here, so there are certain conditions. So many of the students used to take F net is equal to ma whenever they are being asked what is Newton's second law. F net is equal to ma formula is applicable only if mass of the object is constant. Let us see. There are two types of numericals here we are going to get. One is mass is constant, another one is of velocity of the object is constant. If mass is constant, let us see what kind of numericals we are going to get, and velocity is constant. So if mass is equal to constant, then this above formula can be converted as F net is equal to as mass is constant, this terminology, second terminology, V into dm by dt is going to become 0. Now I am left with only one formula, that is m into dv by dt, where dv by dt is equal to acceleration, then F net is equal to mass into acceleration. This formula is applicable only if mass of the system is constant. Next, if mass is variable and velocity is constant, then if velocity is constant and mass is variable, then F net is equal to first terminology is going to become 0. dv by dt is going to be 0 because velocity is constant. Remaining term is v into dm by dt, rate of change of mass. It is called as rate of change of mass. This formula is actually useful in solving rocket numericals. So in solving rocket numericals, we are going to use this formula a lot. So what's the meaning of dm by dt? Dm by dt is nothing but rate of combustion of a fuel in rocket numericals. So the meaning of dm by dt is rate of combustion of fuel in rocket numericals. Okay, let me start solving these equations based on Newton's second law. So this is the exact answer. Whenever you are being asked to what about Newton's second law, this is the formula you have to answer. What is Newton's second law? M into dv by dt plus v into dm by dt, or F net is equal to dp by dt, rate of change of momentum. Okay, let's get started. So the force acting on a particle of mass m is indicated by force time graph as shown in the figure. Okay. The change in momentum of the particle over the time interval from 0 to 8 seconds they are asking. Okay. So they are given a question with respect to force, change in momentum and time. Then the formula that I have to use is Newton's second law. So second one, solution. What is Newton's second law? F is equal to dp by dt. They are given force and they are asking change in momentum. Then send this dt to left side. It is going to be F to dt is equal to dp. I need momentum, change in momentum. Integrate on both sides. You are going to get momentum. Left side limits are from t1 to t2. Right side limits are from initial momentum to final momentums. So whatever the terminology of different integration or differentiation, look at here. So now integration is in terms of time. That's the reason I took limits from t1 to t2. Here integration is in terms of dp, that is change in momentum. That is the reason limits are in momentum. Understand that terminology. Okay. So from this, what is integral dp? Integral dp is going to be p. So you can replace it as p initial, p final, which is equal to p final minus p initial, which is represented as change in momentum. Change in momentum. This is what we have to find out. This is also called as change in momentum. This is also called as impulse. What is it? This is also called as impulse. Remember, it is also named as impulse. Linear impulse or angular impulse? It is a linear impulse. Remember. Now, so change in momentum is equal to integral t1 to t2 f dt. Okay. So they are given force versus time graph. Finding integration. Integration is nothing but area under the graph. So area under graph, force versus t. Okay, just observe the areas. So let's say this is A1, A2, A3. Then area delta P is equal to area A1. As this is A2, S2 is negative area. That is the reason I am going to subtract that negative area from the positive area plus A3. So what is positive area? 1 by 2. What's the value of base? 0 to 2 difference is 2. Height is going to be 6 minus A2 area. You just observe only sides because I've already represented. I did already represented minus here. If you represent minus again, you are going to get wrong answer. Don't do that. Okay. So 2 to 4 difference it is 2, and height it is 2. 0 to 3 difference is 3. Next. Plus 4 to 8 difference is 4 and height is going to be 3. So this difference I am telling, this difference is going to be 3, guys. Next, so here it is 2 2s are, you are going to get 6 minus 6 plus 12. So change in momentum is equal to 12 Newton second. This is the answer for the given question. Which option matches? Option 2. Be careful while you are answering this question. So many students used to answer by taking positive second area, A2 as a positive area. If you take positive area, you are going to get total answer 24 units. 24 Newton second. That option is also there. That is the first option that they have given in the question. So be careful while you are answering. You just have to subtract negative area from the positive area whenever you are finding area under the graph of force versus time graph. Okay. So let's move on to the next question. A stone is dropped from a height h. It hits the ground with a certain momentum p. Okay. If the same stone is dropped from a height 100% more than the previous height, the momentum when it hits the ground will be. Okay. So let us see. Whenever any stone is dropped, so from a certain height, let us say that height is going to be h here. I am imagining it is as h. So from height h, if any stone is dropped, let me find out velocity with which it is going to hit the ground. So the formula is v square is equal to u square plus 2as. Initial velocity is equal to 0. Then v square is equal to 2 into a is minus c. I have already said whenever object is moving downward or upward, doesn't matter, a must be taken as minus g, and the displacement when it is moving down, you should take it is in the form of a negative. So it is minus h. So v square is equal to 2gh and v is equal to root 2gh. This is the velocity with which that object will hit the ground. This is velocity. What about momentum? Momentum is equal to mass into velocity, which is m into root of 2gh. Relation between momentum and height is equal to root h. So okay, now next case, what they are saying, the same stone is dropped from a height 100% more than the previous height. So right now object is dropped at a height 100% more than the previous one. Now h is increased. So if h is increased, what's the original value of height h? h1 is equal to h2. Then what about h2? h2 is equal to h is the original height. Now it is increased 100% of h. It is going to be increased. This is how you have to represent the value of percentage increased value. Okay, if it is decreased, you just have to substitute here as a minus. That's all. Then h is a plus. This 100% can be replaced as 100 by percent, in the sense by 100 into of represent into h. 100 will get cancelled. You are going to get 2h. This is going to be the final height, second case height. Okay, we know that momentum is directly proportional to root h, right? Let me find out final momentum with which it hits the ground when object is dropped from a height of 2h. As momentum is directly proportional to root h, I can write it down as P1 by P2 or P2 by P1 is equal to root of H2 by H1. What's the value of H2? H2 is equal to 2H by H. H will get cancelled. Then P2 is equal to root 2 times of P1. So let me answer this directly. So the way how we have to answer directly is this P2 can be represented as, so root 2 value is actually 1.414, right? It is 1.414 times of P1, you can write it as P1 plus 0.41 P1. Okay, that means whatever the extra value other than original value, that is going to be the increased value. 0.41 can be represented in the form of percentage as 41% is improvement is happened. So which option is correct? Option B is correct. That's the way you have to answer. Okay, ma? Understood? Next, question number 4. Let us see. A body under the action of force 6i cap minus 8j cap F bar is equal to 6i cap minus 8j cap plus 10k cap. Okay. Acquires an acceleration of 1 meter per second square. Acceleration is equal to 1 meter per second square. Okay. The mass of this body must be, okay, so force is equal to, let me find out magnitude of force, which is equal to root of 6 square plus 8 square plus 10 square, which is equal to root of 6 square plus 8 square is 100 plus 100. You can write it is as 10 root 2. So this is going to be 100 root 2, sorry, not 100 root 2, 200. So root of 100 into 2, then 100 comes outside, you are going to get 10 root 2. This is the magnitude of force acting on that particle. Acceleration is magnitude is also known, then mass is equal to F by A, where F is 10 root 2, acceleration is 1, mass of that object is equal to 10 root 2 kg. Which option is correct? Option C is correct. Okay. Next, question number 5, solution. A sand is being dropped on a conveyor belt at a rate of m kg per second. Okay. So let's say a conveyor belt is there. That means which carries the things. So which makes the things move from one position to another position. Okay. So let's say this is how it is. So a sand is being dropped, let us say. So from this bag, a sand is being dropped. At what rate this sand is being dropped? This sand is being dropped at the rate of m kg per second. Okay. The force necessary to keep the belt moving with a constant velocity v meter per second will be. So this conveyor belt is moving with a constant velocity v. Then what is the force required to move it? Let the belt move with a constant velocity. So what's the formula for Newton's second law? Newton's second law is dp by dt. So we know the formula, that is m dv by dt plus v dm by dt. In this case, they said velocity is constant, so this term is going to become 0. The only formula that I am left with, F is equal to V into dm by dt. dm by dt is the rate of change of mass. They have already given rate of change of mass is m kg per second. Let me represent that. Then F is equal to V into m is the answer, and this is the required force further on the belt to make the belt move with the constant velocity. So which option is correct? Option C is correct. Now look at question number 6. What's the head one? An object of mass 3 kg at rest. Now force of this value is applied on the object. Then velocity of object at t is equal to 3 seconds. Super. So mass of the object is given. Solution. Mass of the object is 3 kg. Okay. So force acting on that is 6t square plus 4t, 6t square I cap, 4t j cap. Okay. First of all, find out acceleration to find out velocity. Acceleration is equal to F by m, right? Okay. It is going to be 2t square I cap plus 4 by 3 into t j cap. This is the value of acceleration. What's the question they're asking? So they're asking a velocity of object at t is equal to 3 seconds. By if I know the value of acceleration, how to find out velocity? A is equal to dv by dt. So from this I need velocity. Velocity is equal to integral a dt. So as the integration is in the form of dt, limits must be from t1 to t2. This is the way to find out velocity when acceleration itself is given. Okay, let me start integrating. From where to where? I need exactly at t is equal to 3 seconds, right? So okay, so let me integrate this equation, then we'll substitute that. Integral, so 0 to 3 seconds, acceleration is 2t square I cap plus 4t by 3 j cap into dt. So if we integrate, we are going to get 2t square integration is going to be 2t power 3 by 3. Limits are from 0 to 3 I cap. Next 4 by 3 to t square by 2. Limits are from 0 to 3 j cap. So 2 by 3. So if we substitute 3 square 9 square, sorry, not 9 square, 9 times of 3, it is going to be 27. It is going to be 27 I cap. So I substituted upper limit and lower limit. So let me show you the clear representation of substitution of upper limit and lower limit, which is equal to 2 by 3 into, it is going to be 3 square minus 3 cube minus 0 cube, upper limit minus lower limit. This is I cap. 4 by 3, so into 2 will get cancelled out. So 2 ones are 2 2s are 2 by 3 into 3 square minus 0 square into j cap. This is the way of representation. 2 by 3. So in the 3 cube minus 0 cube is going to be 3 cube only. 1 3 will get cancelled. You are going to left with 3 square. 3 square is 9. 9 into 2, 18 I cap plus. So 1 3 square will get cancelled. You are going to get 2 3s are 6 j cap. This is the value of velocity of the particle at t is equal to 3 seconds. It is 18 I cap plus 6 j cap. Option B is correct. Next, a cricketer catches a ball of mass 150 grams in 0.1 second, moving with a speed 20 meter per second. Then he experiences a force of, okay, seventh one solution. Mass of that ball is 150 grams. Convert that into kg. 150 into 10 power minus 3, which is equal to 0.15 kg. Okay, velocity initially with which it is moving is 20 meter per second. So the cricketer catches this ball of mass 0.15 kg, which is initially moving with 20 meter per second, in 0.1 second. That means in 0.1 second, velocity of the object came to rest. So initial speed is 20 meter per second, final speed is equal to 0. Then he experiences a force of, okay, they are given mass, velocity and time relation, and they are asking force t is equal to 0.1 second. You can immediately go to the Newton's second law, that is F is equal to dp by dt. So change in momentum, final momentum minus initial momentum. Final momentum is 0 because velocity of the object finally it is 0. So finally that object comes to rest position when cricketer catches that ball. So it is going to be 0. So initial momentum alone you have to consider, that is mass into velocity divided by time. Mass of the object is 0.15 kg. The object is ball here, into velocity. Velocity is 20 divided by time of this process is 0.1. Then 0.1 can be written as 1 by 10. 1 by 10 goes to numerator, it will become 200. So 200 into 0.15, it is going to be 30 Newton. That's the answer. Question number 7, answer B is correct. Okay. So it is also called as impulse. Change in momentum is nothing but impulse. So with the help of change in momentum, we are finding this answer. Next. If the force on rocket moving with a velocity of 300 meter per second is 210 Newton, then the rate of combustion of fuel, again same process. Let us say so a rocket is moving up by burning a fuel with a constant velocity. Velocity is equal to constant. So because of burning of this fuel is burnt in opposite direction to the motion of the object. This is action reaction pair. Then F is equal to dp by dt. You can directly apply this formula. As velocity is constant, you can write it down as v is equal F is equal to v into dm by dt. They have already given force required, which is equal to 210 newtons, which is equal to velocity is 300 meter per second. I need a rate of combustion of fuel. Rate of combustion of fuel is dm by dt. So 0 will get cancelled. It is going to be 0.7 kg per second is the rate of combustion of fuel, dm by dt. This is the way to answer. Look at the next question. A bullet is fired from a gun. Okay. The force on the bullet is given by F is equal to, question number 9 solution. F is equal to 600 minus 2 into 10 power 5 into T. Okay. Where F is in Newton and T is in second. The force on bullet becomes 0 as soon as it leaves the barrel. Okay. So let's say force became 0 when bullet came out of gun. Let us say the moment when bullet comes out of the gun, so force acting on the bullet is equal to 0 when it came out. So if it is equated to 0, you can find out the time. 600 minus 2 into 10 power 5 into T. So 2 into 10 power 5 into T is equal to 600. So 2 3 times and T is equal to 3 into 10 power minus 3 seconds. This is the time taken by that bullet to come out. What's the question? What is the average impulse imparted to the bullet? Okay, impulse is change in momentum. F is equal to dp by dt, right? So from this I need momentum. Then dp is equal to F dt. As force is variable, we have to integrate from initial momentum to final momentum. Bullet is initially at rest, so initial momentum is equal to 0. So we need change in momentum, right? Or impulse. So it is delta p is equal to change in momentum. Limits from t1 to t2. Initial time is equal to 0. t2 is the time at which bullet comes outside. At that moment, force acting on it equal to 0. So integral 0 to 3 into 10 power minus 3. Force is 600 minus 2 into 10 power 5 into T dt. Let me integrate this. So 600 into T, limits are from 0 to 3 into 10 power minus 3 minus 2 into 10 power 5. T limits, if integration of T is T square by 2, limits are from 0 to 3 into 10 power minus 3. 2 will get cancelled. So 600 into 3 into 10 power minus 3 minus 5 into T square is 9 into 10 power minus 6. So it is going to be 18 into 10 power minus 2, which is equal to 1.8 minus, so 9 5s are 45 So there is no phi here, that's a phi representation is wrong here. It is not phi, it is 10 power 5. 10 power 5. So answer is going to be 9 into 10 power minus 1 will be there, which is equal to 0.9. 1.8 minus 0.9. The answer is going to be 0.9 Newton second. So this is the answer. Which option? Option D matches. Next. Question number 10. A 500 kg rocket is set for vertical firing. Okay. 10th solution. Let me represent with a simple diagram. So mass of this rocket is equal to m is equal to 5000 kg, not 500 kg. The exact speed is 800 meter per second. Okay, so v is equal to 800 meter per second. To give an initial upward acceleration of 20 meter per second. Upward acceleration is 20 meter per second square. Okay. The amount of gas ejected per second to supply the needed thrust will be. Okay. So as there is a fuel here, so the fuel is burning in opposite direction to the motion of this rocket. Now as fuel is burning, its mass is going to decrease slowly. That is what we have to find out. They are asking us to find out dm by dt. Okay, so thrust is equal to, general formula is F is equal to m or v into dm by dt, right? F is equal to v into dm by dt. So what is the F here? Force here. Force is the weight of this rocket against which you have to apply. So this force is acting against the weight of that object. Weight of that object is m into g. As there is an acceleration mentioned here, this fuel burns in opposite direction with a pseudo force. That pseudo force will be in opposite direction to acceleration of the container, which is g plus a. Just because of acceleration of the container, we are going to get it is as mg plus a, then v into dm by dt. So mass of the rocket they have given it is 5000. Acceleration due to gravity given in question itself, which is 10, plus acceleration of this rocket is also given, which is 20, which is equal to velocity with which it is moving is 800 dm by dt. So dm by dt is equal to 50 by 8 into 30. It is going to be 1500 divided by 8. So if you solve this equation, you are going to get answer approximately 187.5 kg per second. That's the answer. So which option matches? Option B is correct. Next, 11th question. A force of 6 newtons acts on a body at rest. Okay. Initially, object is at rest position. How much force is acting? 6 newtons of force is acting. Mass of that object is 1 kg. During this time, the body attains a velocity of 30 meter per second. Okay. So after certain interval of time, it gains a velocity 30 meter per second. The time for which the force acts on the body is. Okay, super. So they're asking time for which the force acts on the body. So you can write down F is equal to dp by dt. Momentum of the body is changing, right? So you can write down mass into final velocity minus initial velocity divided by time. So they are asking time taken. So t is equal to m into v final minus v initial divided by f. Mass of the body is 1 kg. Final velocity is 30. Initial velocity is 0. Divided by force acting on it is 6. Then t is equal to 5 seconds. This is the time taken by that object to gain a velocity of 5 meter per second. So option B is correct. Next, question number 12. A 10 newtons force is applied on a body to produce in it as an acceleration of 1 meter per second. So F is equal to 10 newtons. So applied on a body, acceleration is equal to 1 meter per second square. The mass of the body they're asking, so mass is equal to F by M only, no, sorry, mass is equal to F by A, which is equal to 10 by 1, which is equal to 10 kg. What is there to answer? Useless fellows. Next, which option? Option C is correct. Okay, next question number 13 solution. So this kind of question already we solved, same numerical we solved. They gave force is equal to 6 I cap minus 8 j cap plus 10 k cap. What about magnitude of the force? Magnitude of the force is equal to root of 6 square plus 8 square plus 10 square, which is equal to root of 100 plus 100. 6 square plus 8 square is going to be 100. So final answer you are going to get 10 root 2 Newton. This is the magnitude of the force. And acceleration of the object is 1 meter per second square. The question they are asking is mass of the body. So mass of the body is equal to F by A, and F is equal to 10 root 2 by 1, which is equal to 10 root 2 kg. That's the answer. I think already we solved this numerical in this session itself. Next, question number 14. In a rocket, fuel burns at the rate of 1 kg per second. That means I told you F is equal to V into dm by dt is the formula that you have to use for rocket numericals. They gave dm by dt itself, which is equal to 1 kg per second. Okay. This fuel is ejected from the rocket with a velocity 60 km per second. Okay. So velocity they are given 60 km per second. 60 km per second convert into meter per second. 60 into 10 power 3 meter per second. The question they are asking is force exerted on the rocket is equal to F is equal to V into dm by dt. That's all. V into dm by dt is 60,000. 60 into 10 power 3 into this is velocity into dm by dt is 1 kg. So which is equal to 60,000 Newton. So which option matches? Option B is the correct answer. So many students used to make a mistake here. Without converting 60 km per second into 60 meter per second, don't solve the problem, because all the units must be in a same. Correct, right? Next, question number 15 solution. A satellite in a force-free space sweeps stationary interplanetary dust at the rate of dm by dt, which is equal to alpha by v. Very good. Dm by dt is given as alpha into v. This is rate of change of mass. Okay. So what is the force formula for retarding force? So where m is mass, v is the speed of satellite, and alpha is constant, the acceleration of the satellite. Super. They are asking acceleration of the satellite. So first of all, let me find out force. So force is nothing but change in rate of change in momentum, right? Which is equal to dm by dt, which is equal to v into dm by dt. Super. So what's the value of dm by dt? They have given alpha into v. Then v is equal to, F is equal to v into alpha into v, which is equal to alpha into v square. This is the force. Sweeps interplanetary dust where m is mass, is so acceleration of the satellite. So force free space sweeps stationary interplanetary. Okay, there is an opposite force which is called as a retardation force. It is going to be negative. Then acceleration is equal to negative. So F by m, which is equal to minus alpha v square by m is nothing but capital M. So which option matches here correctly? Minus alpha v square by m. Option D is correct. Next question number 16. Solution. A particle of mass small m is moving with uniform velocity v1. It is given an impulse such that its velocity becomes v2. The impulse is equal to. The formula for impulse. Impulse is nothing but change in momentum. So impulse is nothing but change in momentum. Where mass is constant, I can write it as v2 minus v1. That is the formula for change in momentum. Which option? Option D is correct. Next. So question number 17. Solution. A 600 kg rocket is set for vertical firing. Okay. What's the mass of the rocket? 600 kg. M is equal to 600 kg. Exhaust speed is 1000 meter per second. Okay. 1000 meter per second. The mass of the gas ejected per second to supply the thrust needed to overcome the weight of the rocket is, it is going to be F is equal to V into dm by dt, which can be replaced as, in place of force you have to replace this force with m into g, which is equal to V into dm by dt. What's the question they're asking? We have to find out dm by dt. So from this, dm by dt is equal to m into g by v. So mass of this rocket is 600 into acceleration due to gravity 10 divided by the value of velocity. Velocity is 1000, which is equal to 6 kg per second. So which option? Option C is correct. Very good. Next, question number 18. Question number 18 is based on Newton's third law. So look at question number 18. So what is Newton's third law? Newton's third law is, so for every action there will be an equal and opposite reaction, right? Okay, let us see. A rigid ball of mass m strikes a rigid wall at angle 60 degrees and get reflected without loss of speed as shown in the figure. Okay. So this is the diagram. They're asking the value of impulse imparted by the wall on the ball will be. They're asking impulse in the sense they're asking change in momentum. Okay, so let us see. So to find out a change in momentum, mass into final velocity minus initial velocity is the formula. I should know what is initial velocity and final velocity. Here they have given speed with which that ball is hitting the ground or striking the wall. Okay, now I have to divide this into two components. Then only I can represent velocity. Okay, so let me represent this into two different components: horizontal component of velocity and vertical component of velocity. This is how it is represented. So if this is 60 degrees, this angle is going to be 90 degrees, and this is going to be 30 degrees, and this is 60 degrees. Opposite angles are 60 degrees. So horizontal component is V cos 60 degrees, and this is going to be V sin 60 degrees. Let me represent initial velocity. Initial velocity is equal to V cos 60 I cap minus V sin 60 j cap. V cos 60 I cap minus V sin 60 j cap. Cos 60 is 1 by 2. So V by 2 I cap minus V root 3 by 2 j cap. This is the initial momentum, initial velocity. Okay. Let us see final velocity. So without change in speed, this object is coming back after hitting the wall. Okay, let me divide this into two components again. So as this object is moving in this direction, let me assume it is starting from here. Divide this into two components. This is horizontal component, this is vertical component. Okay, so if this is 60 degrees, I think this is also 60 degrees, then this component is going to be V cos 60 degrees, and this is going to be v sin 60 degrees. Let me divide this into two components and represent. V final is equal to, V final is minus V cos 60 I cap minus V sin 60 j cap. So minus V cos V by 2 I cap minus V root 3 by 2 j cap. This is final velocity. What's the question they're asking? They're asking change in momentum, nothing but impulse. So how to represent a change in momentum? Delta P is equal to mass into V final minus V initial. This is the way to represent. So M into V final is minus V by 2 I cap minus root 3 V by 2 j cap. Next, minus V by 2 I cap plus V root 3 by 2 j cap. So which is V root 3 by 2, V root 3 by 2 will get cancelled. So I'm left with, so M into minus V by 2 I cap minus V by 2 I cap. It is going to 2 times of V by 2 I cap. So 2 will get cancelled. Minus M V I cap is the change in momentum, and the magnitude is equal to magnitude of impulse is equal to M into V. So look at the option which is matching. Option 1 is correct. Very good. Next. Question number 19. A body of mass capital M hits normally a rigid wall with a velocity v and bounces back with the same velocity. Okay. Question number 19. Let's say this is a rigid wall. A body of mass M hits normally a rigid wall with a velocity v. So this one hits normally. So after hitting, it bounces back with the same velocity. It is bouncing back with the same velocity, mass M, velocity v. Okay. The impulse experienced by the body they are asking. So impulse is nothing but change in momentum. Change in momentum is mass into final velocity minus initial velocity. See, whenever you observe this kind of questions, most of the students used to answer initial it is v, final it is minus v, so answer is going to be 0. Don't think like that, because we need to find out impulse, that is final velocity minus initial velocity. M into final velocity direction, towards left or towards right? Towards left. So that's why it is going to be minus v I cap minus initial velocity is v I cap. This is where students are getting confused. So as I am taking forward direction as positive and opposite direction as negative, this is the rule I am going to get, which is equal to minus 2mv I cap. So finally impulse imparted, they are asking magnitude. So magnitude is equal to 2mv. Which option matches? Option C. That is how we have to answer. Next, look at the question number 20. In question number 20, they said a 0.5 kg ball moving with a speed 12 meter per second strikes a hard wall at an angle 30 degrees with the wall. Okay. Let me represent it. So follow the terminology they have given, then we can easily understand it. A 0.5 kg ball moving with a speed of 12 meter per second. Okay. 0.5 kg moving with 12 meter per second. Strikes a hard wall at an angle 30 degrees with wall. So this is wall. With respect to wall, it is making an angle 30 degrees. Okay. Next. So it is reflected with the same speed at the same angle. It is reflected with the same speed at the same angle. Okay. it is reflected back with the same speed and at the same angle. Speed is going to be 12 meter per second itself. If a ball is in contact with the wall for 0.25 seconds, so t time of contact of the ball with the surface is 0.25 second. Okay, what's the question they're asking? The average force acting on the wall. Super, they're asking average force. So average force acting on the wall is equal to change in momentum by change in time. Okay, what change in momentum is mass into final velocity minus initial velocity divided by time. Now I have to find out initial velocity and final velocity. Okay, let's observe. So initial velocity is equal to, divide this velocity into two components. Let us see. So horizontal component of velocity and vertical component of velocity. So if this is 30 degrees and this is also going to be 30 degrees, opposite angles, then this component is going to be 12 cos 30 and this is going to be 12 sin 30. This is the way to represent and divide that component. So it is 12 sin 30 I cap minus 12 cos 30 j cap. As it is downward, I represented it is as minus j cap. It is 12 sin 30. Sin 30 is 1 by 2. 1 by 2 into 12 is 6 I cap minus cos 30 is root 3 by 2. Root 3 by 2 into 12 is 6 root 3 j cap. This is Vi, initial velocity. Okay. Next, how to represent final velocity? Let me divide that into two components. So divide it into two components, horizontal and vertical. So as this is 30 degrees, this is also 30 degrees, then 12 cos 30 and this is 12 sin 30. This is the way to divide this into two components. Let me represent the final velocity. Final velocity is equal to 12 minus 12 sin 30 I cap minus 12 cos 30 j cap. So which is equal to sin 30 is 1 by 2. 1 by 2 into 12 is minus 6 I cap. Next minus 6 root 3 j cap. This is final velocity. So I have to find out force, average force important. Let me substitute here. Average force is equal to mass of the object is 0.5 into. So in this formula you just have to substitute all these values. 0.5. So final velocity is minus 6 I cap minus 6 root 3 j cap minus initial velocity 6 I cap plus 6 root 3 j cap. Check out it. Final minus initial. So minus 6 I cap minus of minus, it is going to become plus. So divided by. So what is the time of contact? Time of contact is 0.25 seconds. Okay, what? Okay, so F average is equal to, let me answer this. So here 6 root 3 will get cancelled out and we are going to get minus 2 times of 6 I cap. So 0.5 into minus 2 times of 6 I cap divided by 0.25, which is equal to 0.25 can be written as 1 by 4. 4 goes to numerator. 2 into 0.5 is 1. So minus 6 I cap divided by 1 by 4. 0.25 can be written as 1 by 4. 4 6 are 24 minus 24 I cap. So magnitude of average force is equal to 24 newtons. So this is vector. So which option is correct? Option C is correct. Super. Next, question number 21, solution. A body of mass 3 kg hits a wall at an angle 60 degrees and returns at the same angle. The impact time was 0.2 seconds. The force exerted on the wall. Okay, same question, same model. So this is the diagram they have given. A body of mass 3 kg hits a wall at an angle 60 degrees and returns at the same angle. The impact time was 0.2 seconds. the force exerted on the wall, they have already given impact time, that is equal to 0.2 seconds. Okay, so let me find out. We can use the tricks also, so many times, so 6 tricks you cannot remember, no problem. There is a possibility for making a mistakes while you are taking minus and positive values here. No need to go through that, you just can take the components, that is the easiest way to answer. Okay, let me divide this into two components, horizontal and vertical. If this is 60, this is also 60. The speed is 10 meter per second, divide that into components. 10 cos 60 and this is 10 sin 60. Next, divide this into two components, final velocity, this is also 60 degrees, it is going to be 10 cos 60 and this is 10 sin 60. So let me represent in the formula F is equal to mass into final velocity minus initial velocity divided by time. So in this formula we have to substitute mass of this object is 3 kg, final velocity is minus 10 cos 60 I cap. So cos 60 is, let me substitute it directly, cos 60 is root 3 by 2. I am writing it here. So this is final velocity. Sin 60 is root 3 by 2. Root 3 by 2 into 10 is going to be 5 root 3. And this one, sin cos 60 is 1 by 2. 1 by 2 into 10 is 5. So 10 cos 60 is 5. 10 sin 60 is 5 root 3. Let me substitute those values directly. So which is minus 5 root 3 I cap. Next, minus 5 j cap. Minus 5 I cap plus minus of minus, it is going to be 5 root 3 j cap. So 5 root 3 will get cancelled out. Okay, it is not getting cancelled out here, it means there is a small mistake in the representation of an angle here. So let me revise this. This is not the 60 degrees angle. This is not opposite angle. Let me replace it. And it is represented here as, it is divided into horizontal component and vertical component. So this is going to be angle, opposite angle. So it is going to be 10 meter per second is the velocity. Vertical component of velocity is going to be 10 cos 60. Horizontal component of velocity 10 sin 60. 10 cos 60 is going to be 5 and 10 sin 60 is going to be 5 root 3. Let me represent that. Hope you understood the representing angle here. So this is how we have to write it down. So 10 sin 60 is going to be 5 root 3. 10 cos 60 is 5. Let me substitute in the formula and then we can find out the final answer. That is F is equal to m. Mass of the object is 3 kg. Final velocity is, now it is going to be correct, minus 5 root 3 I cap. This is the final velocity. Minus 5 j cap. Next, plus 5 root 3, or plus, you are going to get minus. So plus 5 root 3, no, not plus, final velocity minus initial velocity, right? Minus 5 root 3 I cap. Minus of minus, it is going to be plus 5 j cap. So plus 5 j cap minus 5 j cap will get cancelled out, divided by time will be there. Time is 0.2 seconds. So it can be represented as 0.2 second can be written as 1 by 5. 5 goes to numerator. So 3 into 5 is going to be, which is equal to 15 into minus 2 times of 5 root 3 I cap. Let me consider only magnitude. This is force representation. and magnitude of force acting on the wall is equal to 15 into 2 into 5 root 3, which is equal to 150 root 3 is the answer, Newton. So which option is matching? Option A is the correct answer. Very good. The next questions are based on law of conservation of momentum. So look at this. The meaning of law of conservation of momentum is momentum remains constant in the process. It means net force acting on the system is equal to 0. So we know the formula, that is Newton's second law, force versus change in momentum relation, that is F is equal to dP by dt. So if F net acting on the system is equal to 0, dP by dt is equal to 0. So from this dP is equal to 0, it means change in momentum is 0. Change in momentum is 0, but not momentum is 0. So here, if change in momentum is 0, when force is equal to 0, when momentum acting is equal to constant, then only F is equal to 0. What is differentiation of constant? Differentiation of constant is 0. If F is equal to 0, then momentum must be constant, but change in momentum is equal to 0. It can be replaced as initial momentum, final momentum is equal to 0. Initial momentum minus final momentum, whereas initial momentum is equal to final momentum. This is the meaning of law of conservation of momentum. Try to understand the representation clearly. Okay. Look at question number 22 and let's try to solve that question. Try to pause the video and try to answer by your own. Then you will get an idea. If you are not getting the answer, just go ahead with the video. Okay, let me start. An object flying in air with a velocity 20 I cap plus 25 j cap minus 12 k cap. Okay. Velocity of the object, initial velocity is equal to 20 I cap plus 25 j cap minus 12 k cap. Suddenly breaks into two pieces. Super. Suddenly breaks into two pieces whose masses are in the ratio 1:5. Okay. So particle is suddenly breaks into two pieces. Initially it is not at rest position. Initially it is moving. Let us say mass of the particle is m. They didn't give mass of the original object, but they have given ratio of the particles after explosion. Okay, this is divided into two pieces. So their masses are m1 and m2, and masses ratio m1 is to m2, which is equal to 1:5 they have given. Okay, the smaller mass flies off with a velocity. Okay, we don't know which one is the smaller mass. Okay, m1 is to m2 is equal to 1:5, right? Definitely m1 is smaller mass. So smaller mass velocity they have already given, that is v1 is equal to 100 I cap plus 35 j cap plus 8 k cap. Then the velocity of the larger piece they are asking. Velocity of the larger piece. Okay. Before solving this question, I would like to give you a small note. Try to understand. Whenever, see, majority of the questions based on law of conservation of momentum will be based on explosion of a particle. So if any particle is exploded, is it exploding because of its internal forces or because of external forces? Explosion is because of internal forces. Let's say a block of mass m is exploded. If it is exploded, it is because of internal forces. It is because of internal forces. If it is exploding because of internal forces, external force acting on the system is equal to 0. If external force acting on the system is equal to 0, momentum is going to be constant. Momentum is equal to constant, or you can represent change in momentum is equal to 0, which is initial momentum is equal to final momentum. So this is the process you have to remember when you come across numericals based on conservation of momentum or explosion of any particle. Okay. Now at one more point I have to, this is note 1. One more point is, when any object is exploded into different ratios, let's say a particle m is divided into 3 different ratios, then how to find out mass of that particle? M1 particle mass, M2 particle mass and M3 particle. Let's say m particle is divided into ratio m1 is to m2. How to find out m1 alone? Try to remember the trick. m1 can be written as m1 into total mass. Instead of this, I'll represent a ratio in the form of some other ratio. Let's say a to a is to b. So it is divided into the ratio a is to b. Okay. Then to find out mass of the particle 1, so m1 is equal to ratio of that part a into total mass of the object divided by sum of the parts of the ratio, that is a plus b. This is the way to find out exact mass of the particle which is exploded or divided into pieces. Okay, next, what about m2 mass? M2 mass is that ratio, that is b into total mass divided by a plus b. This is the way to represent or find out mass of the individual objects after explosion. Try to remember these points. Then we'll go ahead. Now if you observe here, they've already given masses ratios, that is 1:5. As there are only 2 objects, it's not that much difficult to answer the question. So what's the formula for initial momentum, they said? Now initial velocity of the object is given, so mass of the object is, let's say, m. Okay, so as it is being exploded, it is because of internal forces, not because of external forces. So change in momentum is equal to 0. If change in momentum is equal to 0, initial momentum is equal to final momentum. So initial mass of the particle is m and its initial velocity is 20 I cap plus 25 j cap minus 12 k cap, which is equal to second. So m1 particle mass, next divided into 2 particles, m1 into velocity of the particle is 100 I cap plus 35 j cap plus 8 k cap. This is final momentum of the first smaller particle. What about momentum of the large particle? m2 into v, we don't know. Let's say that is represented as v bar. We have to find out v bar. Do we know mass of the individual particles? We don't know. I gave you the trick how to find out mass of the individual particles. How to find out mass of individual particles? I said I imagined mass of the particle as m and it is divided in the ratio 1:5. Then how to find out m1? m1 is equal to 1 into m by total ratio 6. What about m2? m2 is equal to 5 into m by total ratio, it is going to be 6. This is how we have to divide that into different ratio. Okay, let me get into this. So mass of the particle is m into 20 I cap plus 25 j cap minus 12 k cap, which is equal to m1 is m by 6, 100 I cap plus 35 j cap plus 8 k cap plus m2 is 5m by 6 into v bar. M will get cancelled. 6 comes as a multiplier here. So it is going to be 120 I cap plus 25 6 25 4s 100, 25 6 is 150 I cap minus 12 6 72 k cap, which is equal to 100 I cap plus 35 j cap plus 8 k cap plus 5 v bar. So send this to left side, which is equal to 5 v bar is equal to 120 minus 100, it is going to be 20 I cap plus 150 minus 35 is 115 j cap Next, minus 17. If you send 8 left side, it will become minus 80 k cap. So from this, V bar is equal to, divide right side equation with 5, you are going to get 5 4s are 20 plus 23 times of 5 is going to be 115 minus 16 5s are 80. So this is going to be the answer. 4i cap plus 23j cap minus 16k cap. Look at the option. Which option is matching here? Question number 22. Option, first option is the correct answer. Okay. So let's try to solve question number 23. 23 question is also of same model. That is explosion of a particle. So an explosion breaks a rock into 3 parts. So it's just previous question, just to explain you, I took this much time. This question I am going to solve in a less time. Only it is based on the law of conservation of a momentum. I told you already, whenever you come across numericals based on explosion, it means explosion is happening because of internal forces, not because of external forces. So external force acting on the system is equal to 0, then change in momentum is equal to 0. As change in momentum is equal to 0, initial momentum is equal to final momentum. Now look at the question. An explosion breaks a rock into 3 particles in a horizontal plane. 2 of them go off at right angles to each other. Okay. So look at the diagram. Initially, object is at rest position. Now it is divided into 3 particles after explosion. So 2 of them are moving perpendicular with each other. Okay. So 2 of them go off at right angles to each other. The first part of mass 1 kg. Let's say this is 1 kg mass. Next, second part. So first part is moving with 12 meter per second. Second part of mass 2 kg. Okay. Moving with a velocity 8 meter per second. If the third part flies off with a velocity 4 meter per second. Okay. They have already given velocity also, which is equal to 4 meter per second. We don't know in which direction it is moving, and we don't know mass of that particle also. That is what they're asking. Then its mass is, let's say, m. Okay. As I said, this question is based on law of conservation of momentum because of it is an explosion. Initial momentum of the particle is 0. So an explosion breaks a rock into 3 pieces, in the sense initially that object is at rest position. So initial momentum is equal to 0. Final momentum, as object is divided into 3 particles, that I have to write down m1 v1 plus m2 v2 bar plus m3 v3 bar. One more hint they have given is object 2 particles of different masses are moving perpendicular to each other. Let me represent them with respect to direction, because it is a velocity. Velocity is a vector quantity. We must represent with direction. Okay, so it is 12 j cap. Try to understand. Mass of the particle is 1 kg. 1 into velocity 12 j cap plus mass m2. It is going to be 2 kg. Velocity is 8 meter per second, which is in I cap direction, plus m3. We don't know, that is m, and velocity is going to be 4 meter per second. Okay. So from this I have to find out m. So 4m is equal to minus 12 j cap plus 8 is nothing but 16 I cap. So which is, if you get cancelled, this one 4 3s are minus 3. Here we are going to get minus. So minus 3 j cap minus 4 I cap. I need magnitude. So m is equal to root of 3 square plus 4 square. Root 3 square plus 4 square is root 25. Then m is equal to 5 kg. This is the answer. Mass of the third particle is going to be 5 kg. Which option is correct? Option D is correct. Let me solve question number 26. So it is somewhat controversial question. So whatever the option they have given in NEET examination, those options are wrong. Okay, so whatever the answer we are going to get, that answer it is not there in the options, it is given a grace mark at that time. Let me explain you this question, then we'll decide what is going to be the correct answer. Okay, so question number 24. Let me read it out slowly. It is also based on law of conservation of momentum. Okay, a person holding a rifle, mass of the person and rifle together it is 100 kg, stands on a smooth surface and fires 10 shots horizontally in 5 seconds. Okay, super. So let me consider a person who is standing on a smooth surface, who is holding a gun and firing bullets. Okay, so as this surface is smooth surface, whenever bullets are coming out of this gun, bullets will move forward, a person will tries to move towards left because of the smooth surface. Okay, this is what happening here, and this kind of process is happening because of internal forces, not because of external forces. So that's why momentum is going to be constant. F net is equal to 0. All these things you have to consider. F net acting on the system is equal to 0, change in momentum is equal to 0, initial momentum is equal to final momentum. So bullet and gun and person both are initially at rest position, so initial momentum of the system is also equal to 0. Now I have to find out final momentum. So final momentum in the sense, initial momentum is 0 because both gun and the person both are at rest position, that's why initial momentum is equal to 0. Now final momentum is also equal to 0. What about final momentum? Final momentum in the sense after firing. Final momentum in the sense after firing. Okay, so after firing, bullets and this person and gun system also gets separated here. So let me represent that. Okay, so mass, it is going to be gun and man system plus bullet, which is equal to 0. Momentum of the gun and man system and momentum of the bullet is equal to 0. This is how we have to decide. Okay, so what is the mass of the gun and bullet? So you are releasing only how many bullets? 10 shots, in the sense 10 bullets you are releasing. Each bullet mass is 10 grams. It is going to be almost negligible. There won't be much change in the mass of the gun and man system, which is equal to, I am representing with it is capital M into V, velocity of the gun. Next, mass of the bullet into velocity of the bullet. Here it is not only one bullet, there are some n bullets are coming out. That's the reason I must represent it with n. Okay, M represent mass of the gun and man system, which is equal to 100 they have already given. So you may ask me that as bullets are coming out, there will be reduction in the mass of the gun man system. Yes, there will be, but whatever the reduction in the mass is negligible because of each bullet mass is 10 grams only. So on that too only 10 bullets are coming out. That is the reason I am neglecting the reduction in the mass of the gun man system. So okay, hope you understood. So 100 into V plus, what's the mass of the each bullet? Mass of each bullet is 10 grams into velocity is going to be 800 into how many bullets are coming out? 10. So convert 10 grams into kgs. Let me convert that. 100 V plus 10 into 10 power minus 3, right? At 10 power minus 3 I am writing it as a denominator. So 800 into 10. So into 10. So this 3 zeros and these 3 zeros will get cancelled. You are going to get 80. So 100 V is equal to minus 80 and V is equal to minus 0.8 meter per second. So this is the velocity of the gun and man system, in which they are moving in opposite direction to the velocity of the bullet. Okay, we got the velocity of gunman system. So that is what they are asking. The final velocity acquired by the person, okay, that is equal to minus 0.8 meter per second. They are asking average force exerted on the person, okay. So average force exerted on the person can be calculated again. F is equal to dp by dt. So they have already given in how much time these 10 shots are being fired. That means number of bullets which came out in 5 seconds they have already given. Now I have to find out change in momentum. Change in momentum is mass of the bullet into final momentum minus initial momentum divided by time taken. How many number of bullets are there? N number of bullets are there. Let me find out that. F is equal to dp by dt. Mass of the each bullet is 10 grams converted into 10 power kgs. It is going to be 10 power minus 3. Final velocity of the system. So what is the velocity of the bullet, which is equal to 800 meter per second? Initial velocity is equal to 0 into number of bullets which are coming out, which is equal to 10 divided by time taken in this process is 5. So finally we are going to get F is equal to, so this 10 zeros will get cancelled out. So it is going to be 80 by 5, 80 by 5, which is equal to 16 newtons. This is the answer, force exerted. So if you observe G minus 0.8 meter per second and F is equal to 16 newtons, it is not at all there in the options. Then what should we have to do? It is actually options are not given in the question. So this is the correct answer. Okay. Look at question number 25. 25 question number is again also based on explosion. Okay. So let's try to answer as fast as possible. Question number 25 solution. An explosion blows a rock into 3 parts. Okay. Original particle mass, let's say m. They didn't mention it. Did they mention? No. Okay. I think we did solve this question. So 2 particles go off 1 kg, first part moving with a velocity of 12 meter per second, and 2 kg, second part moving with a velocity 8 meter per second. If the third part flies off with a velocity 4 meter per second, its mass would be, I think 5 kg is the answer. Which question we solved? Here it is. Question number 23 and question number 25 both are same. Okay, no need to solve. You just go through the question number 23. So we are going to get the same answer. Next, question number 26. Question number 26 solution. A 1 kg stationary bomb is exploded in 3 parts having masses 1:1:3 ratio. Okay. Original mass of this object is 1 kg. Initially it is at rest position. That is the meaning of 1 kg stationary bomb. Now it is exploded. Is it because of internal forces or external forces? It is because of internal forces. Exploded. So exploded in the sense net external force acting on the system is equal to 0. If external is equal to 0, now total momentum, change in momentum is equal to 0. So momentum of the system is constant, that is initial momentum is equal to final momentum. Okay. Masses of the particles are in the ratio 1:1:3. So I gave you a short trick to find out the mass of the individual particles. So m1 is to m2 is to m3 is equal to 1:1:3. So what about m1? m1 is equal to 1. What is the total mass of the object? Total mass of the object is 1 kg. So 1 into total mass divided by sum of the parts, which is equal to 5. So which is 1/5 kg is the answer. Next, what about m2? m2 is equal to, 1 into 1/5, which is 1/5 kg. Next, What about m3? M3 is equal to 3 into 1 divided by 5, which is 3 by 5 kg. This is the way to represent mass of the individual particle. Okay, so parts having same mass move in perpendicular directions with a velocity 30 meter per second. Okay, now this is exploded. After explosion, so two particles which are having equal masses, that is m1 and m2, are moving in perpendicular directions with speeds 30 meter per second and 30 meter per second with the same speed. They are asking mass of the velocity of the bigger particles. So this is m3. They are asking velocity of this particle. Okay, so we know that change in momentum is equal to 0. Initial momentum is equal to final momentum. Initial momentum of the system is equal to 0 because initially bomb is at rest position. So final momentum is, there are three particles, so m1 v1 bar plus m2 v2 bar plus m3 v3 bar, which is equal to m1 is mass of the first particle, that is 1 by 5 kg, into v1 is 30 j cap. It is a velocity, you must represent with direction. Next, plus m2 is equal to 1 by 5, velocity is going to be velocity of the particle 30 meter per second along I cap, plus m3 is 3 by 5 into v3. That is what I have to find out. 3 by 5 into v3 is equal to minus 1 by 5 into 30 I cap minus 1 by 5 into 30 j cap. So 5 will get cancelled, 30 tens. So this is 10. We need magnitude of the velocity of the third particle. Magnitude of velocity is equal to root of 10 square plus 10 square. It is going to be 10 root 2. This is the answer. Which option is matching? Option A is correct answer. Next, question number 27. Let me answer that. A mass of 1 kg is thrown up with a velocity of 100 meter per second. After 5 seconds, it exploded into two parts. Okay, one part of mass 400 grams comes down with a velocity 25 meter per second. Question number 27. A mass of 1 kg is thrown up with a velocity of 100 meter per second. Okay. So 1 kg mass is thrown up with 100 meter per second. After 5 seconds, it explodes. Okay. So let me find out velocity after 5 seconds first. So it took 5 seconds. So v is equal to u plus 80. So final velocity is equal to 100 minus acceleration due to gravity is 10 into 5. So you are going to get 50 meter per second is the velocity at the time of explosion. That's the velocity. We have to consider initial velocity as a for initial momentum. This is equal to 50 meter per second. Okay. After explosion, here it is. After 5 seconds, it explodes into two parts. One part of mass 400 grams comes down with a velocity 25 meter per second. Okay. So after 5 seconds, this is divided into two particles. So one particle is moving down of mass 400 grams with a velocity 25 meter per second. Another particle of mass must be 600 grams which is moving with a velocity v. That is what we have to find out. Okay, again initial momentum is equal to final momentum. So we know the process. Initial momentum in the sense momentum before collision, final momentum in the sense momentum after collision. So initial momentum before collision of the object is, so mass of the object which is moving upward, that is 1 kg into velocity of the object is 50. As it is moving upward, let me represent it with this j cap. Okay, next, So final momentum, object is divided into two particles. One particle of mass 400 grams is moving downward. As it is downward, I can represent it is as minus 25 j cap. Next, plus another particle of mass 600 grams, velocity is going to be v plus j cap. Okay, as j cap you can cancel it out, as we have only one direction, either plus or minus you can take. Okay, now try to solve this question. You are going to get the answer from this calculations. 50 is equal to, this 400 grams can be written as 0.4 kg and this is 0.6 kg. 0.4 into 25 is going to be 10 minus 10 plus 0.6 into v. So 0.6 into v is equal to 60. Then v is equal to 60 by 0.6, which is equal to 600 by 6, 100 meter per second is the velocity. So which option is matching? Option C is correct. Hope you understood. Next, question number 28. A shell in flight explodes into 4 unequal parts. Which of the following is conserved? Obviously momentum is conserved. So because it is exploding because of internal force or external force? Internal force. So external force is equal to 0. So change in momentum is equal to 0. Nothing but initial momentum is equal to final momentum. Super. So momentum is conserved. Next, which option is correct? Option B is correct. 28. Next, 29. In question number 29, they said a man fires a bullet of mass 200 grams at a speed of 5 meter per second. The gun is of mass 1 kg. By what velocity the gun rebounds back? Okay, 29 solution. So change in momentum is equal to 0 again, because F external is equal to 0. It is happening because of internal forces. Initial momentum is equal to final momentum. Initially bullet and gun system is at 0 velocity, so initial momentum is equal to 0. Mass of the gun into velocity of the gun plus mass of the bullet into velocity of the bullet. 0 is equal to 200 grams. Mass of the bullet is 200 grams at a speed of 5 meter per second. 200 into 10 power minus 3 into 5 meter per second. Mass of the gun is of 1 kg. Velocity v. That's what we have to find out. So v is equal to, so 0.2 into 5 is going to be 1. So I think it is going to be 1, but it is in opposite direction, minus 1. Minus 1 meter per second. So magnitude of this velocity is equal to 1 meter per second. So minus 1 represent gun moves in opposite direction to the velocity of the bullet. Okay, so option A is correct. Next, so question number 30. Hope you understand how to solve numericals based on conservation of momentum. So in question number 20, they said a body of mass 5 kg explodes at rest into 3 fragments with masses in the ratio 1:1:3. Okay. Initial mass of the system is 5 kg. Explodes at rest into 3 fragments. It is initially at rest, so initial momentum is equal to 0. Okay, now explodes into 3 fragments. Okay, the explodes into 3 fragments. So they said the fragments with equal masses fly off with equal velocities. The equal velocities they have given is 21 meter per second. This is also 21 meter per second. The velocity of the heaviest fragment they are asking. Okay, velocity of heaviest fragment. That is what we have to find out. Okay, I told you how to find out mass of the individual object. they have given ratios m1 is to m2 is to m3 is equal to 1 is to 1 is to how much it is 3. So which is m1 is equal to 1 into what is the total mass of the object, 5 kg. Okay, so 1 into 5 divided by 5, which is equal to 1 kg. Next m2 is equal to 1 into 5 divided by 5, which is 1 kg. Again m3 is equal to 3 into 5 divided by 5, which is equal to 3 kg. These are the masses of the individual particles. Let me say this is m1 and this is m2 and this is m3. I have to find out velocity of the third particle, which is equal to, according to law of conservation of momentum, delta p bar is equal to 0, which is initial momentum is equal to final momentum. Initial momentum of the system is equal to 0 because initially it is at rest position. So 0 is equal to, it can be represented as m1 v1 bar plus m2 v2 bar plus m3 v3 bar. Mass of the first particle m1, which is moving in perpendicular directions, it is 21 I cap plus 1 into 21 j cap plus m3 3 into v3. So 3 v3 is equal to root of 21 square plus 21 square, which is equal to 21 root 2. Then v3 is equal to 7 root 2 meter per second. This is the velocity of the third particle. Option A is correct. Hope you understood, guys. Very good.